Hey there, welcome to this video. This is 9-5 and we are going to integrate some inverse trig function. Now, that does mean there are more formulas that you're going to have to memorize, but the good news is there's only about two really that we're going to need for the AP exam. So let's go ahead, let's meet those two. Since the derivative arcsine of u is u prime over 1 minus u squared, and the derivative arctan of u is u prime over 1 plus u squared, it follows that their antiderivatives are of the same setup. So the integral of u prime over the square root of 1 minus u squared dx is arcsine of u plus c. And also the integral of u prime over 1 plus u squared dx is arctan of u plus c. Now, there are some kind of little nuances that we're going to have to go ahead and adjust these formulas. So here are some basic integration rules. In these formulas, they rarely will you see them as 1 minus u squared or 1 plus u squared. Generally, they have an a value, which follows these forms. So the integral of u prime over the square root of a squared minus u squared dx is arcsine of u over a plus c, and the integral of u prime over a squared plus u squared dx is equal to 1 over a arctan of u over a plus c. Okay, and note, since that arcsine and arccosine differ only in sign, it's not necessary to have a third integration rule for arccosine, so that's why we're leaving it out. Now, the main thing that you're going to have to do with integrating these formulas is be able to identify the type of form. Like, does the problem setup follow the arcsine form, or does it follow the arctan form? And the easiest way to identify this is that arcsine will always have a square root in the denominator. Okay, notice the arctan does not, so that's how we kind of know what type of inverse trig function are we integrating. Okay, so let's go ahead and notice too these a's kind of pop up, and we're like, what the heck are these a's? We didn't see these when we're talking derivatives. Well, let's go ahead and warm up our brains. So here, differentiate y is equal to arcsine of x over 2. So go ahead, pause me, please do that. All right, so hopefully you have paused the video, and we're going to go ahead and take the derivative here of this function, okay? And thus, y prime is going to be equal to 1 over the square root of 1 minus x over 2 quantity squared times the derivative of the inside, which is 1/2. Okay, and if I go ahead and clean this up, this is 1 over 2 times the square root of 1 minus x squared over 4. Now, what I want you to do is I want you to imagine that 2 is the square root of 4. So I have the square root of 4 times the square root of 1 minus x squared over 4. Okay, and if I go ahead and multiply these in, what we get are 1 over the square root of 4 minus x squared. Okay, and in this case, right, you can notice your a value, which is in these here. So there's your a value, right, and your a value would be 2. A equals 2, and your u is x. Okay, so that's going to be kind of the strategy that we're doing when we're integrating, is identifying, okay, first of all, what form? There's a square root, so I know that this is arcsine form. Okay, what's my a value? Well, that's the one without the variable. Okay, so the square root of 4 is 2, so a is 2. All right, what's my u, or my function? In this case, it's simplistic, it's just x. So therefore, I know that this integral is going to be arcsine of u over a. U over a. X over 2 plus c. There it is. Very, very simple, right? Okay, so let's go ahead and check out example 2. Example 2, again, what type of form is it in? Well, I notice there's no square root, and there's a plus. This is arctan form. arctan form. Okay, so what is my a value? What's the a? Well, here, remember, it's without the variable, so a is 5. Okay, what's u? Well, u is here. What's the square root of that? And that would be 2x. Okay, so notice too with this problem is a little different too. Well, actually, not different. This is like kind of the main stuff you'll see. Notice u is a function, right? So what's the derivative? U is a function. U prime is 2. So we're going to need that as a hook, okay? So I'm going to go ahead, I'm going to rewrite this. This is the integral of 1 over squared plus 25, okay, times, and then here's our hook. I'll put it in a different color. 2, there's no x, so we're just a 2 dx. Now, since I introduced a 2, what do we have to do? We have to balance it. So we'll go ahead and balance it. And now I can go ahead and integrate. Okay, so this is equal to 1/2, right, times, okay, now I have arctan of u over a. Okay, so this is going to be 2x over 5. All right, and notice too with the arctan, you have to multiply, and we put it out front by 1 over a. Okay, so here, 1 over a. So our 1 over a value is 5. So I'm going to put 1 over 5 right there. Okay, plus c. And there's your answer. Simple, right? Very, very simple. Okay, let's go ahead and check out a couple more examples. All right, so on number 3 and 4, notice they look similar, but there's a little trick going on with number 4, which we'll get to in a second. But if we look at number 3, okay, what type of form is this? Well, there's no square root, and I see a plus. I know that this is an arctan form, okay, with my u being 2x again, and then my a value is square root of 3. Okay, I have a u that's 2x, so therefore I'm going to need, again, a u prime, which is 2. But notice, I have an 8 here. So what I'm going to go ahead and do is I'm going to split up this 8. Okay, so I have the integral, okay, integral. And if I want to pull off a 2, what factor remains? Well, that's 4. So I'm going to factor out the 4. And then I have 1 over 3 plus 4x squared. Okay, and then that 2, so here's the hook, right, 2 dx comes out front. All right, now we'll go ahead and integrate. So this is equal to 4 times, okay, and I forget this time, 1 over a, so 1 over a, which is root 3, okay, arctan of u over a, so 2x over square root of 3 plus c, and that's it. See, these aren't so bad, right? It's identifying u, identifying a, identifying arctan, just some identifying, and then that's it. Very, very simple integration. I think these are easier. Number 4, okay, so here's Admiral Akbar. It's a trap. On number 4, notice how I have an x in the numerator, and then we have x's in the denominator. So this is not inverse trig. Not inverse trig. Okay, so that should be a big, huge flashing sign. Notice we haven't had any variables in the numerator. So what you're going to have to do is investigate the function in your denominator. I'm going to say, hey, if my denominator is this function, what's the derivative of it? What's u prime? And that would be, lo and behold, 8x. So really what you're looking at, right, and don't freak out, we're not going to do u substitution, but it helps to see it, right? Don't you have a u prime, or a 1 over u times u prime dx situation, which is natural log. This is natural log. Okay, so just to help you kind of see it, I'm going to rewrite this. This is the integral of 1 over 3 plus 4x squared. Okay, and then here's your hook. Your hook is 8x dx. Okay, so that's going to go away. And then your answer is the natural log of the absolute value of 3 plus 4x squared plus c. And there you have it. That is it. All right, I'm going to go ahead and split the video here. I want to work out a couple more examples. All right, I will catch you next time. Peace.